3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Congratulations, you just left the Earth behind. And right now, your body is already beginning to change. Not tomorrow, not next week. Right now, in this very exact second, the engines cut out. The roar fades to silence. Through the window, Earth is already shrinking away beneath you. And inside your body, something strange has started. Within minutes, your blood begins moving toward your head. Your face starts to swell, your legs actually get thinner, and your brain quietly realizes that gravity, the one force it has trusted every second of your life, has simply disappeared. This is the fluid shift. On Earth, gravity constantly pulls the fluids in your body down toward your feet. Take gravity away, and roughly 2 liters of that fluid go rushing upward into your chest, your neck, and your face. Astronauts describe it as feeling permanently congested, like having a head cold that never goes away. Their faces look round and puffy in orbit, cheeks fuller, eyes a little narrowed. Their legs shrink so much the crews nicknamed it bird legs. But the puffy face is nothing compared to what happens after your first night in space. Because now your inner ear is in crisis. Deep inside your ear are tiny organs that sense gravity and tell your brain which way is up. In orbit, they suddenly have nothing to measure. Your eyes say one thing, your ears say another, and your brain cannot reconcile them. The result is space motion sickness. Somewhere between half and 3/4 of all astronauts experience it in their first few days. Headaches, nausea, vomiting that arrives with almost no warning. Even your sense of taste changes. With all that fluid pooling in your head, your sinuses stay blocked, and food tastes dull and flat. It is why so many astronauts crave hot sauce and shrimp cocktail in orbit, chasing any flavor strong enough to break through. And sleep becomes its own puzzle. There is no lying down when there is no down. Astronauts zip themselves into sleeping bags strapped to the wall, arms drifting in front of them, chasing rest in a body that no longer knows if it is upright or upside down. Many report strange, vivid dreams and broken, restless nights. But if you thought your stomach was confused, wait until your skeleton finds out gravity is gone. Because here's the strangest part. It is not that your body starts to weaken. It is why it weakens. Your muscles and bones are lazy by design. They only build themselves as strong as they need to be. On Earth, simply standing up is a constant workout against gravity. Remove that resistance, and your body makes a logical decision. It stops maintaining tissue it no longer thinks it needs. Within a single week, the effects are already measurable. Astronauts can lose up to 20% of their muscle mass in under 2 weeks if they do nothing to fight it. Their bones lose density at a rate of around 1% every single month, more than 10 times faster than an elderly person with osteoporosis on Earth. This is why astronauts on the International Space Station exercise around 2 hours every day. Treadmills with harnesses that strap them down, resistance machines that mimic the pull of weights. Without that relentless routine, their bodies would simply melt away the strength they arrived with. Even your heart is affected. On Earth, it works hard to pump blood upward against gravity. In orbit, with that job suddenly gone, it can actually begin to shrink and change shape, growing more rounded and spherical over just a few weeks. But here's the part doctors did not expect. The most troubling changes were not in the muscles or bones at all. They were in the eyes. When astronauts began returning from long missions, many needed stronger glasses. Scans revealed the backs of their eyeballs had physically flattened, and their optic nerves were swollen. Scientists gave it a name: spaceflight-associated neuroocular syndrome. The leading suspect is that same upward fluid shift, raising pressure inside the skull and pressing on the eyes for months on end. And it went deeper than vision. Studies found that the immune system becomes confused in orbit, with some functions weakening and dormant viruses occasionally reactivating inside the body. The community of bacteria living in the gut shifts. Even the skin thins and becomes more sensitive. We know all of this in remarkable detail because of one extraordinary experiment. Astronaut Scott Kelly spent nearly a year aboard the space station, and here is what made his mission unique. He has an identical twin brother, Mark, also a former astronaut, who stayed on the ground. For the first time, scientists could compare two people with the same DNA, one in space and one on Earth. The NASA twin study tracked everything: genes switching on and off, changes in Scott's immune system, shifts in his gut bacteria. Even the protective caps on the ends of his chromosomes, called telomeres, behaved unexpectedly, lengthening in orbit and then rapidly readjusting once he came home. The reassuring news is that most of these changes reversed after he returned to Earth. But not all of them, and not quickly. Some markers took months to settle back to normal, and a few never fully returned to where they started. And that is what worries scientists most about going further. Because everything described so far happens under a kind of shield. The space station orbits close enough to Earth that it still sits partly inside our planet's magnetic field, which deflects much of the dangerous radiation streaming through space. Astronauts up there are protected in a way they would not be anywhere else. On a journey to Mars, that shield disappears completely, and there is nowhere left to hide. Out in deep space, crews would be exposed to a constant storm of high-energy particles from the sun and from distant exploding stars. This radiation can slice through DNA, raising the long-term risk of cancer and potentially damaging the brain and nervous system. It is one of the single biggest obstacles standing between humanity and Mars. We can engineer rockets. We can pack enough food and water. We can shield against the cold. What we still cannot fully solve is how to keep a human body intact through years of exposure with no magnetic field to hide behind. Add the steady drain on bone and muscle over such a long trip, and the challenge becomes enormous. So imagine you stayed, not for days, not for months, for an entire year, drifting far from the world that built you. You would come home changed, slightly taller, sometimes by as much as 2 inches, because your spine stretched without gravity compressing it. Weaker in the legs, needing help to stand as your body relearns its own weight. Your heart, your eyes, your bones, your blood, every system quietly rewired by a place they were never designed for. And that is the real lesson hidden in all of this. We did not evolve to live out there. We evolved for exactly one planet. Every cell in your body, every bone, every drop of blood expects the steady pull of Earth's gravity. It is written into your biology so deeply that you never even notice it. Take that gravity away, and your body does not break. It does something far stranger. It begins rewriting itself, adapting to a world it was never meant to survive in. Which raises a question almost too big to hold. If humans one day settle on Mars, where gravity is only a third of Earth's, and stay not for a year, but for generations, children born and raised under that weaker pull, then what happens to the human body over centuries? What do we become after hundreds of years? After thousands? Would we still even recognize them as human? The astronauts orbiting above us right now are not just explorers. They are the first test subjects in the longest experiment our species has ever run. An experiment to answer one simple question: can a creature built for one world ever truly belong to another? We are only just beginning to find out the answer. If you want more journeys like this, hit subscribe. There is a whole universe left to unveil.